here we're going to have the example that's almost like our previous example for the z statistic, but there's going to be a little bit of a difference here. So it says, say a pizza delivery company claims that the average delivery time is 30 minutes. You, the researcher, believe the actual time is greater than. So greater than is important, just like before. That's going to determine our research hypothesis. Greater than that based on personal experience. So you think the time takes longer, but you don't know exactly the average time. So let's go ahead and write our hypothesis. So our null is still going to be mu equals 30 because that's the claim. And remember, the null always has an equal sign. The alternative is going to be less than, greater than, or not equal to that number. So we have to pick one of them. And we're going to do greater than because we think it's greater than 30. So look for keywords when you find your research hypothesis. We also, from this first sentence, we see that the average delivery time is 30 minutes. So this is the population mean because it's their claim. It's what we're trying to prove or disprove. We don't have the population standard deviation. They didn't tell us that in this example. In the other one they did. This example is a little different. So that means we have to use a t. So let's keep reading. You take a random sample of 100 delivery times. So that's going to be our sample size. That's how many observations we have. And you find a sample mean of 31. So that's x over bar. And a standard deviation of 5. So this standard deviation is talked about when we talk about the sample. So that will be S instead of sigma in this example, because this example is a t-statistic example. But what happens is you're going to calculate it very similar to before. So first you want to find the standard error, and I'm going to calculate that separately first over here. Or you can put it all into one formula if you want, it doesn't matter. So it's going to be the sample standard deviation divided by the square root of n. So the square root of n is just 10. So we have 5 over 10, which equals 0.5. Or 1/2. And then to get the t, you take the sample mean minus the population mean from the null and divide by the standard error. So we're going to get 1 divided by 0.5, which is 2. So we still get 2 even though we're using a t-statistic in this example. Now, if we really had a sample standard deviation and we compare it to the population standard deviation, in reality it wouldn't really be the same probably, unless it was just by chance. But in this example, just to make it easier, I made it the same. Alright, so for our greater than research hypothesis, you want to make your distribution. It's still going to look bell-shaped, but we're going to have a t-statistic here. Again, we have the 2 here, because that's what we just calculated. Your 0 is still in the middle. And you're going to shade to the right because we had a greater than hypothesis. So this is our example, but what if? So let's do a what if here. So what if we had our research hypothesis be less than? Then we would make this. We would still put our 2 here. But because it's less than, we would shade to the right. What if it was a not equal to sign in our research hypothesis? Then we would put the 2 here. we would make the negative version. So you want to make the version that you don't have already. So if it was a -2, then you put a 2 as well. And then you take the -1 and shade to the left, and take the +1 and shade to the right. So this is just the what if on the right. The left is what goes with our problem. Let's see, you want to see the patterns that you have, and no, there's only a certain amount of things you can do, just like in the last phase. If you want to find p-values for a t-distribution, you have to use Excel. There's not a t-table for that. If you're doing confidence intervals, then there is a t-table for that. You can also use the t-table if you conduct a hypothesis test the critical region way. I have a video from someone else on YouTube that explains the critical region way. I decided to not teach you that way because this is the way that researchers do it in psychology. This is how they do it when they write research articles. In most statistics class, though, they do teach you the critical region way for a t-statistic, because I think it's because on test you can't really use Excel very easily, so it's easier to do the critical region way if you're using a table. But I think it's more practical to know how to do it in Excel and do the p-value way, because that's how it's reported in actual research. No one does the critical region way in research, but it is nice to know how to do it that way, so you can look at a z or a t statistic and just kind of eyeball it and see, oh, is that a big z or a t statistic? So anything above 2 is usually a pretty big z or t statistic, and usually in a lot of cases you're going to have a significant result. But it depends on your sample size for the t distribution, and for a z or a t, it depends on your alpha level. But a 2 is usually a big enough z or t statistic, or a -2 and below is also large enough in the absolute value sense. But anyways, here is how to get the p-value in Excel. So we had t equals 2, our n was 100, so that means our degrees of freedom are going to be 99. And let's find the percentile first. So I'm going to show you how to do it just how you did it in the z-table to find the percentile, and then use that to find your p-value. I'm going to show you that way first. So we're going to put an equal sign in a random cell and put t dot dist, and that, sorry, I'm doing this one-handed because I have a microphone in the other hand. But you put t dot dist and then put your t value for the x, comma, your degrees of freedom, which are 99, and then always put true. True gives you areas, not just an individual value, just that line. So always put true in this class. So that will get our percentile, and it's close to what we got for the z distribution. For the z we got 0.9772, I think. So it's pretty close. It's going to be a little bit more. And then to get, the greater than, right? Remember, we would subtract the percentile. So you can just click here to get it. And so this would be the p-value. Another way to get it just directly is to do the t dot dist, and then you want to do the dot rt because we want the right tail, right? This is for the greater than. So this is another way to do it. So we'll get the same thing. So this way was the 1 minus the percentile, and that kind of goes along with how we did it when I taught you how to do probabilities with the z-table and the probability phase. This way is just a more direct way. But this way you have to remember different functions for different research hypotheses. But you can do it this way. So this one, the t dot dis dot rt is for a research hypothesis that's greater than. So the right-tailed one. Now if it's a less than hypothesis, then you just do the percentile. So we just do what we did before. So see how 3 of them are coming up? The one without anything at the end, the t dot dist, that would be for the percentile. So you can use that percentile to find any other probabilities for less than, greater than, or not equal to. Or you can just use it for the less than hypothesis if you want. So this is just if it was less than. You don't do them all 3 at once. I'm just showing you what if it was a less than research hypothesis. If it was a not equal to, then you can do the negative version and multiply it by 2. So I'll show you 2 ways. So you could do t dot this and then do -2 and then put true. And so this is the negative version. This is the percentile for the negative t. And then you take that and multiply it by 2 because it's symmetric. Or maybe a quicker way would be t dot this and then dot rt. Oh, sorry, not rt. 2t for two-tailed. And then you put the 2. I think you have to always put positive t here. I don't think it takes negative. So that just took that and doubled it automatically. So let me make sure, yeah. T dot this dot 2t. So if you put a negative, and this one, yeah, it doesn't work. So you have to put the positive version if you use the dot 2t. If you do the other way and find the percentile first, put the negative t value and then here and then double it. So I showed you 2 ways for the greater than or the not equal to. You can decide which way makes more sense to you. The first way I showed was just to use the percentile function, which is the t dot dist with nothing at the end. And then you can do 1 minus that percentile to do the greater than research hypothesis. Or you can do that function, the t dot dist, and enter the negative t value. Get that percentile and then double it for the not equal to research hypothesis. So that's one way. That's kind of how I showed you with the z-table, because the z-table only gives you percentiles. Or what you can do is for the greater than, you can do the t dot dist dot rt for the right side. That's what the rt stands for. And for the not equal to sign, you can do the t dot dist dot 2t. And that gives you two tails. Two tails. But you have to use the positive t value. You can't put a negative there. Okay? So if it was a negative t statistic, just make it positive for the only for the dot 2t. Alright, hopefully I didn't confuse you more by showing you more ways. But there you go. If you're confused, just look in the t distribution example for the hypothesis test, and it gives you a more simplified way to do it, which is just using the percentile function and doing it the z-value way by subtracting or doubling it or whatever.